Alright, so now we're going to work on number 17. So it says if P and Q are subsets of the universal set U, with the three sets defined as follows: U is blah blah blah, P blah blah blah, Q. So it says also remember that if not specified, the elements in an interval will be an infinite set of real numbers. So it's not going to be any complex numbers, and you can't just assume. The key here is you can't just assume that it's going to be like whole numbers or fractions. It could be anything in between -2 and 1 or 0, 3. So what I wrote down here is I drew a number line. Okay, so U is the main set, the big set, and it's going from -2 to 4. So it does include -2, it does include 4. And so it would be everything in between -2 here and 4 here on the number line. All of that is in U. So I kind of drew a picture here. So here is U. All right, then we have P, which is any x such that x is between -2 and 1. And so here's -2, here's 1. So here you see I have P. Now what I need to do is I need to make sure that we do include 2, we do include 1, because this line right here, I kind of erased it, but that little line under there, that line means we do include it. So we do include -2, we do include 1. Okay, now we have Q, which is x is between 0 and 3. And so you see here's 0, here's 3. And for this one, we do not include 0, so I really need like an open dot. Remember, if you did this in Math 1 or Algebra 1 or whatever, then you have 0 to 3, open dots on both because there are no lines here or here, no lines underneath either of those symbols. So what we need to do, it says write out the set and be careful with the inclusion or exclusion of the endpoints. List the following sets. So P, now this symbol here might be new to some of you. This means intersect. So intersections are where they overlap. So if we look at P, which is the red, so we look at the red, and we look at Q, which is the green, where do they intersect? So to me, you can see, it looks obvious to me that they're intersecting, this area here, right? This is the spot that they're intersecting. So in order for them to intersect, it has to be in both. The number has to be in both. Now, 0 is not in the green one, but it is in the red one, since the red goes over top of the 0. But it's not in the green one, so we do not include it. So this set would be the set of x's such that we need to say between 0 and 1. So we'll do 0. The way I like to do it is put 0, then put x, and then put 1. And then always do less than symbols on both of these. So we're going to do less than. So that means 0 is between, or x is between 0 and 1. And we can close our set. And the key is we got to include 1 since it is in both. You can see the green line goes over it. The red line has the dot. Has this dot here. So we do include 1, but we don't include 0. So that's what we put for part A. Okay, so let's do part B. So what's part B? What's the question? P or Q. So this is union. And that usually we use or. This is intersection, and that you use and. Okay, so P or Q. So the way union works is it can be in either one. It can be in P, it can be in Q. Either one is cool. So P is red here, Q is green here, so it could be in either one. So I like to go, what is the furthest left number that P starts with? Well, that's a 2, -2, and okay, then it ends over here at 1, but then Q goes all the way to 3. So in order to write this as one set that includes both things, it could be in this or this, then we need to go from -2 all the way to 3, but just like in Q, you can't include 3. So our answer is going to be, so what is it, P union Q is all x's such that we're going to go from negative 2 x is less than 3, and we got to include the negative 2 but not the 3. Is that right? Make sure, okay, include that, don't include that. All right, so it looks good. Let's look at C. Moving along here. Sorry, this one's long. Okay, so this one is a complement. This little symbol here is complement. So another way that we say that is not. Okay, so it means it's not in P. But it still has to be in U, the universal set U. So what is not in P? So let's think. So P is from negative 2 to 1, and it can't be in there. So it can be anything, any number out here, but it's got to stop at 4, right? So we want to go from 1 to 4. We want to write that from 1 to 4. We can't include 1 because 1 is in P. So we're going to have an open dot, basically open dot here and a solid dot here. So not P would be the set of x such that we're going to go from 1 to 4. So 1 is less than x is less than 4. We have to think, okay, where do we include it? So we don't want an equal on this one, no equal here, but we do want to equal here. So we want equals here. All right, D. So question D, not Q. So this would be the same thing. Ooh, but this one, notice this one, we have to include this piece over here. Maybe I'll do this in a different color. Let's make it yellow. So not in Q would be this guy with the dot, open dot there, and then all this stuff over here with the dot, closed dot. All right, so open dot here. So it'd be kind of like writing both of these out, writing out both of these. So not Q. Oops, let's not do yellow. Let's do black again. So not Q would be, so in this one we have to write it in two different ways. So let's start with the first one. Let's say from negative 2 to 0. So all x such that x is either in not, from negative 2 is less than x is less than 0. Okay. Sorry, I'm just looking at the book real quick. They're just going to put a comma in between. So they're going to put a comma here. All right, so we want to include negative 2 but not include 0, so we want to include that. And then we have to write this other interval, which goes from 3 to 4. So we'll do 3 less than x less than 4. Okay, we include the 4, we don't include the 3, so include the 4, put a bracket here. All right, E. How many more do we have? All right, E. Okay, so not in P or in Q. That's the way to read this. So think of all of P, all of Q. So P or Q, which we already did, we said is basically P or Q, right here we did, was all x between negative 2 and 3. So from negative 2 to 3, we don't want to be in there. So that's just going to be this little set here from 3 up. So I'll just write the answer on this one to save some time. Oops, I need to... All right, so come on. I don't know what's going on right now. All right, so let's just write the answer. So all x such that we want from 3 is less than x is less than 4. And we don't want to include here, but we do want to include here. All right, so that'll be E. And there's one more, F, not in P and in Q, or sorry, P not in P and Q. So P and Q is this that we talked about earlier. Remember, again, that was from 0 to 1. And we want, let's see if we can do this maybe in orange, from 0 to 1. So we want from here all the way to here, and we did not include 0, but we do include 1. So we don't want to include this, and then this was from here out to here. So not in there would be, it's kind of the opposite of what we have here. So we're going to be from, our set's actually going to include this, so it's going to be the opposite of this, so it is going to include that, and then it's going to be the opposite of this, so this is going to be open dot. I guess I probably need to erase that or something. So that would be an open dot there. Okay, open dot at 0, and then all the way to here. So we'll go from 2 to 0, and from 0 to 4. So we're going to have to write this one in 2. So F, we'll just write it, so X such that, so -2 less than X, less than 0, comma, we'll get to whether or not to include these here in a second. And then the other one was from 1 less than X less than 4. And we need to figure out, okay, so we're definitely including 4. And we said it was the opposite of 0, so we do include that. So we're going to include both these, include that. And we don't want to include that. So the opposite, kind of the opposite of this one, which means don't include 1. All right, and that's it for this one.